Just want to touch base with a statistical measure that you can utilize to pretty much analyze data in the context that I want to see it is in terms of instantaneous voltages. It's kurtosis. You can use this concept or this measure in statistics to check if a distribution how it's performing really, or what are the values like. So baseline kurtosis value of 3 is like a normal distribution. That means you have a symmetrical distribution, on your graph. Okay, so you don't, that means on the right and the left, your distribution, your outliers are pretty much the same. You have like a normal bell curve. Now if you have a value of a kurtosis value of, let's say, greater than 0, it means that you are having a peak, right? That is an offset from the distribution, and it means that your outlier values are more extreme, right? So if you, let's say your value or your kurtosis value is 1, or it means you have an offset. So your normal distribution is 3, your kurtosis value is 1. That means the raw kurtosis value is like 4 because it's offset from the normal distribution. So it's telling you that you have more outlier values and they are extreme values. In this case here, you can see I have a set of a list of voltages, and this is my Python code. Well, I've utilized AI to help me in understanding how to use this, like these libraries. Okay, it took a while to get this thing going. Anyways, bottom line is you have a list and you just want to find you want to use a function kurtosis. It from skippy.stats. You're gonna get that, and you just have to plot a graph. All right, and you're gonna generate a value, which I have here, distribution quart to two decimal places. So if you have a negative value, what it means is like your outliers are pretty much flat. Your values, you might be missing some values in your captcha, so it might not be good. If you have, now here, look at my voltages. Of course, you can pause this video, copy this code, run it in your own script. Just maybe change the whatever is your data, right? Of course, you would need to do, I'm working around here in WSL and using some Python 3.10 version. What else? You might have to download and install some packages, right? Like Seaborn and NumPy, Matplotlib to get this going. So what I did here, I changed from the same voltages. I just changed some of these values, right? You see, I have a 2.07. Here it was 1.07. I put a 2.05. I just wanted to see what's gonna happen. I rerun this script. Now you can see here that my distribution, I'm having a positive kurtosis value of 1.14. That means it's the raw value would be 3 plus 1.14, which is like 4.14. So it's above the normal distribution value. And when it's above the normal distribution value, it means they are more steep. Your outliers are, you have more outliers that are very steep, and these values like 2.07, 2.05, 1.71, compared to the rest of the values here, they are really out, right? So this video is just showing you how you can code this in Python. You just need to change your lists, play with the values, you can plot the graphs. um, um, what I had here was how I actually display these images, right? um, yeah, when I run this graph, when I run it initially, I had like display voltage kurtosis png, and you see my file name here was voltage kurtosis png. In the second case, I just changed the name of the file that I'm gonna store. I call it voltage kurtosis underscore v2 png. That I got like here, and then I just display it here. Okay, and I made a comparison to see when you change the voltages what's happening and how the kurtosis value is changing. So this is all I want to show in this video. You can play with this in Python. So bye for now, guys. Need to sleep. Bye.